Hello friends, today we discussed how we tested white box. As earlier we discussed what is white box, it also called as glass box testing, right? Why it called as glass box? Because in white box testing all logical path decision making statements are tested, right? So kind of source code will be tested, all decisions and all the logical path, right? So white box testing, it can be done by basic path testing. So this is the most important methods of white box testing. It can be done by basic path testing. In this method, the procedure design using basis set of execution path is tested. So in basic path testing, what will happen? Execution path is tested. This basis set ensure that every execution path will be tested at least once. Means we have execution path all paths, and each and every individual path are at least tested once time, right? Now how basic path testing will work? It will have two methods. First one is flow graph notation and second one is graph matrix. Now let's see flow graph notation. What is flow graph notation? This method is include path testing. Following are the steps that are carried out while performing path testing. So step number 1, that is design the flow graph for the program. Step number 2, calculate the cyclomatic complexity. Step number 3, select a basis set of path. And step number 4, that is generate test case for those path. This 4 method is used for flow graph notation. Most important method, that is flow graph and cyclomatic complexity. In GTU exam, it will be asked individually in 7 marks, right? So let's see step number 1 in details, right? Draw the flow graph. Step number 1, draw the flow graph. What is the definition of flow graph? Flow graph is a graphical representation of logical control flow of the program. Means which one is our logical paths, only this will be represented in a flow graph, right? Not like sequence statements and etc. Now second thing is such graph consists a circle. It consists a circle. For example, I am making this graph, right? So this circle called a flow graph node. It's called a node and it represents one or more procedural statements. That means we can suppose we have 3 statements, then one node, then second node and third node, like this. Now this arrow called as edges or links, right? And it represent the control flow. Now in this flow graph, the area bounded by node and edges are called region. Suppose we have one arrow over here, then how many regions are there in this circle? There is a one region inside and second region. Got it? So node and edges are bounded, it's called region. Clear? Now let's see some examples of flow graph. For example, there is a sequence diagram like a sequence statement, right? Statement 1 and statement 2. Then what is the flow diagrams for this sequence? That first we have to draw the node, that statement 1 and statement 2. Clear? So this will work for sequence flow diagram. Now suppose we have if else statement. In if else statement we have true and false condition. One for example, if and else. If it may be a true or it may be a false. So how can we draw the flow diagram for if else statement? This, for example, if statement is here, then we can draw true or false condition and make the node, and whatever result will become is written in this node. This is for if else statement. This is the flow graph of if else statement. Now similarly, for while condition, it may be a true or false conditions, right? So we can draw flow diagram for while statement, that is, for example, we can take while statement. If it is true, then go to here, and false, then it will be exit. So this is for while statement flow diagram. Now for example, there are different cases, then we can draw, for example, case 1, case 2 up to case n, right? So whatever be statement up to case 1, case 2 and case n, it will be shown like this, and whatever result we get will be shown by this node, right? So this is the flow diagram for case diagram. Now you all know the basics of flow diagram. Suppose sequence is there, we can use this kind of flow. If else statement is there, then we can use this type of flow diagram, right? Similarly, now take one example. I already written one example, that is a following program is for searching a number using binary search method, right? So I have one program over here, I already written for searching the binary method. In this, I took the function void search integer key, integer n and integer array of a, right? So this is a function, so we don't need to draw flow diagram for function whatever we take, right? We have to start from statement. So our first statement is what? Integer bottom is equal to 0. So let's the flow make the flow diagram for it. So step number 1, that is our sequence. So let me take step number 1 over here, that is statement 1. Then step number 2, that is statement 2. Now step number 3 is for while condition, right? Now what will be the flow graph for while condition? Suppose we have two condition, while bottom is less than or equal to top, or bottom is greater than top. Suppose while bottom is less than or equal to top, then it will be go in fourth step, right? Then step number 4. Then if this condition is true, then it will be go through 5th step. Then print element is present. So these all are in sequence. So let's make sequence diagram as we earlier discussed. Then step number 7. Now it will be written, right? So if it is written, then it go to 5th statement. Now if a mid is equal to key, right, then it will make second condition that if a mid array of mid equal to key, right, then it will be from step 3 to step number 11, right? And suppose for node 5 a mid is not equal to key, then it will go through if condition. Then step number 8. In if condition there are true or false, then it will be made graph like this 9 and 10. Suppose a mid is greater than key and a mid is less than key, right? Suppose from this bottom equal to mid plus 1 or top equal to mid minus 1. Now for this end of else and end of while, so what we have to do is suppose it's end and this will be end, then it will be go again through step number 3, right? So this way we can draw the flow diagram for this source code, right? Now this way we can draw flow diagram. Now what will be the step number 2, that is calculate the cyclomatic complexity. What are the step number 2? Calculate the cyclomatic complexity. Most important for GTO exam, it will be asked in 7 mark to find out the cyclomatic complexity. For any kind of source code, first of all, if you want to find the complexity, cyclomatic complexity of any kind of source code, then you have to first make flow diagram for that source code, and after that you can calculate the cyclomatic complexity. Now cyclomatic complexity can be computed by 3 methods. First one is first method, that is cyclomatic complexity is equal to total numbers of region in the flowgram, right? What will be the first method? We have to find out total number of region. Now how we find the region? What is the definition of region? That each node and arrows will compute the graph, right? Then it will be called as region, as we discussed in theory, right? In this flow graph, the areas bounded by nodes and edges are called regions, right? So in these flow diagrams, how many regions are there? Let's see. That is, this is the first region, this is the first region, and note that that region must be written in Roman letters, right? This is the first region. What will be the second region? For example, this will be our second region, right? second region, this is our third region, this is our third region, and this will be 4, this will be fourth region, right? What are these? These all are region. So in this program or flow graph, we have 1, 2, 2, 3 and 4, right? 4 region. So total number of region is 4. So directly you can write number of regions, right? Now second method is find out the cyclomatic complexity is equal to E minus N plus 2, right? This is the second method where E means edges and N means nodes, right? Now calculate how many edges in these flow diagrams. First of all, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 12 and 13. There is 13 edges minus how many nodes are there? There are 11 nodes plus 2. So 13 minus 11 plus 2, answer will be 2 plus 2, that is 4. Now you can see that cyclomatic complexity, by finding the edges and nodes, that answer will be 4, and total number of region is also 4. Answer will be same in both method, right? Now third method is cyclomatic complexity is equal to P plus 1. Now what is that P? P is equal to decision making nodes. What is this? P is equal to decision making nodes. How we find the decision making nodes? In this we have 3 decision making nodes. First one is this third one node, and fifth and eighth one, right? So we have 8 decision node is 3, 5 and 8. So we number of P is equal to 3 plus 1, it will also 4. Answer will be same in 3 methods, right? So here this graph complexity number is 4. I hope you all are clear with cyclomatic complexity, right? Now step number 4, that is step number 3, that is select a basic set of path, right? Select a basic set of path. Now path 1, what will be our path 1? That is, first path is 1, 2, 3, 4, 5, 6, 7 and 11, right? This is our first path, and second path is 1, 2, 3 up to 1, 2, 3, 4, 5, 8, 9 and again 3, right? This is our second part. Now what third part? That is 1 2, that is our third path, 1 2 3 up to 11, this is third path, and fourth path is remaining, that is 1 2 3 1 2 3 4 5 8 10 and 3, right? So how many paths are there? There is 4 paths. Path 1 is 1 2 3 4 5 6 7 up to 11. Path 2 is 1 2 3 4 5 8 9 and 3. Path 3 is 1 2 3 11. Path 4 is 1 2 3 4 5 8 10 and 3. This way we can set of path, calculate the set of path, right? Now fourth one is generate test case for path. Generate test cases for our path. In test case, after computing cyclomatic complexity and finding independent basic path, the test case has to be executed for the paths, right? The format for test case is, for example, test case ID, test case name, test case description, test steps, that is in two-way steps, and expected, right? And in last we have to draw test case status and pass whether the test case is pass or fail. Now let's see with example of this following source code. For example, there should be a list of elements arranged in ascending order, right? Means in flow graph we have to arrange elements in order. For example, this will be tested first, then second, right? So let's start to generate the test case. Any kind of test case for path, the format will be test case is like this. Now first one is test case ID, that is, for example, number 1, test case name is validating the based boundaries, validating the based boundary. Now what will be right in test case description, that is checking the bottom and top values for the list of elements, right? Whatever elements we will check for binary test, that is the validity, the based boundaries by checking bottom and top values. So we have to write this test case name description over here. And what will be step? Now what will be our first step? That is bottom equal to 0 and bottom is equal to 0 and top is equal to n minus 1, right? So we have to write step, that is set bottom equal to 0, top equal to n minus 1, check if bottom is less than or equal to top, right, by while loop condition. This condition defines the length of the list from which the key is searched first, right? What will be this condition work? It will be defines the length of the list from which the key is searched, right? And what will be the expected output? That is initial bottom is less equal to top will be true, right? First condition will be true, but during iteration process, lead's length will be reduced and if entire list gets scanned at one point, right? So bottom is greater or equal to top, it will be reached to return, right? Now what will be the test case status? Means we have to write test case status over here, that is this test case will be designed, then we have to write it will be designed. Now suppose if we have any error and it not be work, then we have to write fail, otherwise pass. This all test cases generate, then we have to write pass over here. So this way you have to test all IDs, test case ID one by one. And what we have to test, there should be a elements arranged in ascending order, right? So for example, the element to be searched from the list, its value should be entered and it will be stored in variable key, right? So our first ID is validity, the best boundary. And what will be the test case ID 2? That is checking list element with key, right? This will be our second test case. And what will be the description? Means checking if middle element of array is equal to key value, right? Means we have to write this: if mid is greater than key value, then a mid is greater than key value, right? Like this. And what we have to write in this step, that is set mid is equal to top plus bottom divided by 2. Then compare if mid, array of mid is equal to key, right? And similarly we have to set bottom is equal to mid plus 1, then go to while set top is equal to mid plus 1 and go back to while loop. This way you can write test case. So I hope you clear with test case and flow graph notations, right? And what will be the status? that is design, right? So I hope you all are clear with test case design. Now second method is graph matrix. It will be discussed in second video. Thank you for watching.